Okay.
All right.
So, okay, so the level of significance is 0.05.
Mm-hmm.
So that's not my alpha?
The level of significance, that is your alpha. That
Okay.
is.
So alpha is, so my
So
null hypothesis is bigger than my alpha.
what did you get for your null hypothesis? Or not your null, your what did you get for your p-value? Because what we're doing is we're comparing the p-value with the level of significance.
Okay, that's okay. So like I said, I just totally drew a blank. I was like, what the heck? I was just thinking that's my alpha compared to that, but that makes sense. That would always be that way.
Mm-hmm.
Okay, so p-value, did you plug, is it plugging it in?
Well, no, not in the question. You have to actually get the, I used the Excel sheet that had just a one sample t-test for means, but I put in summary statistics for it. So I put in the mean, which was, well, first of all, I put in the null hypothesis, which is 1.5. Then I put in the sample mean, which is 1.53. The sample was 100, and the standard deviation was 0.17. And I came out with something that was less than 0.05. I can't remember what it was.
What was, so X bar is 1.53. What did you put in for population mean?
So the population mean is mu, and mu is the null hypothesis.
Oh, 1.5.
Mm-hmm.
Sorry, I'm just taking notes when I study. Gosh, why doesn't this stick? Like once I study, it sticks again. But
Yeah,
okay, so then it comes up at 1.764, the z-score.
Yeah, let me plug it in just that way I've got it here.
You said you did z-score for sample size of n?
Well, I did the t-test, which is the z-score basically. Let me put in the numbers again. So 1.5 was the null, and we are doing. So what he's saying is he wants evidence that the mean nicotine content is actually higher. So we're going to do a higher than or a greater than test. The mean that he got was 1.53. Standard deviation was 0.17. And the sample size was 100. So what I came out with was a p-value of 0.0403.
What? Can you share your screen and show me your?
Yeah.
Are you using Excel? Is it one that you created?
I'm using Excel. Yeah, let me show you really quick.
When I met with Brother Richmond the other night, he's like, "Did you make your Excel files?" And I said, "Yeah, but I only ever saw one to make for the dice, the z-score for a single observation and z-score for a sample of n." So is this one that you created, or is this one that
this is
Excel?
This is just, I use the quantitative inference procedures, and I just did a one sample t-test for means. Now I don't have, so if you're looking at my screen right now, let me increase this a little bit so you can see it. So we don't have any variables here because the question doesn't give us anything. But if we don't use this and just use the summary statistics tool right here, what I can do is I can plug in all of these values and it will still give us information about it. So
maybe I'm just not remembering. How do I do that? I don't think, is there a way to do that with SPSS? Well, you probably don't know.
Yeah, I don't know. SPS is definitely not my forte.
Yeah, is that a file within the book?
Yeah, so if you go into any of the lessons, then what
mine doesn't show it. I don't know why. Remember we said that? Mine doesn't show
that's right. That's right. Yeah.
Could you email me that?
Yeah, you bet. So I'm just going to go into lesson 13 here, see if I can find it. And I have a sneeze coming on here, so it looks like it went away.
I could manually. I'm trying to find my notes.
Here it is. So, oh wait, no, that's not the one.
So you're just basically doing inference for independent samples, right?
Yeah. Hang on. Let me find that thing. I know it's in the book here. There's multiple multiple chapters that have that thing in there. I just have to find the Excel instructions. It says, oh, quantitative inferential procedures is what we're looking at. So I'm going to click on that, and that's going to take me to a thing here. So I will copy that, and I will post it to the group chat here for you.
Thank you.
And there's that, so it should pull up now. Anyway, there's 3 different Excel sheets that are on that that link, and the ones that, well, the one that I just used to solve for this question was the quantitative inference procedures.
So okay, so I'm going to ask a really dumb question. We use all 3 of these we use?
Well, we've used 2 of them. I don't think we've used this 3rd one yet.
Okay.
But we have used the quantitative descriptive statistics, and this one is, we use that one to do QQ plots.
Oh, okay.
Yeah.
Okay.
But the quantitative inference procedures is this sheet here. It's the one that has the 1 sample t-test, paired sample, 2 sample, ANOVA. We don't know what that is yet, but anyway, these things we've used so far.
I'm just opening it real quick just to look at it. Okay.
And basically,
okay.
all I did for this question here, question 15, is I plugged in all of these variables. So I know that standard deviation, plug that in to the summary statistic. Let's see, what else did I do? 100 cigarettes, that was the sample, so I put that in right there. The 1.53 was the sample, and then 1.5 was the null hypothesis, and so I plugged all those in there, as you can see. And then
hang tight real quick with me. I'm just looking at your screen.
Yeah.
And my mean is my X bar, right?
The mean is your X. Yeah, the X with the bar.
So then it pulled up your P. Okay, hold on. And then we're looking at. Why am I getting so confused? The p-value.
Mm-hmm. Yep. So we're wanting to get the p-value out of all of this. And now you got to make sure that for this type of test, when you read the question, it says that the person that's doing this research wants to know if the nicotine value is greater than the null. And so for this test, let's go back.
Hold on.
Let's look at
what
it.
was 0.05.
Basically, all it's saying is right now, the cigarettes companies, they say that the nicotine value is 1.5. So that is the null hypothesis. They say this is how much is in it all across the board. So if you get a package of cigarettes, this is how much is going to be in each cigarette or whatever. And the person that's researching says, well, I don't think it's that. I think it's greater than 1.5. I think it's greater than what you say it is. And so basically all we have to do with that information is, at least on the Excel sheet, we put in that it is a greater than test, because you can either do greater than, less than, or not equal to tests.
Okay.
So in this case, we're putting in greater than, because that's what we think it is. We're testing for that. And then we put in all our values, and it'll give us a p-value. That's the important number that we want.
Right, and we're comparing p to alpha, right?
Exactly. And long story short...
So it's less, not more.
Right, exactly. Yep. So the p-value is less than 0.05, so you reject the null.
Okay.
As far as I understood it.
We'll find out, right?
That's right, yep.
Okay. So 16 I didn't do because I hadn't done the problem the right way.
Okay. So I put down independent samples t-test. And let's see if I can work it out really quick. So it's asking the mean number of hours worked for wages by male students and female students, and they're checking to see if those means are different. So
Yeah,
there's so since yeah, exactly, one doesn't have to do with the other, so it would be independent, I think.
okay. I concur. Okay. So then 17, I put dependent sampling.
I did as well, but I put down the fourth one.
Yeah, I put down the fourth, the very last one.
Yep.
Yeah, that's what I did too, because I was like brother, sister. I was just saying they depended upon each other.
Right. Yep.
Okay. All right. And then 18, what did you put?
So I put down A.
Okay, good. So did I.
Good. Awesome.
I don't know why I'm getting hung up on little things.
Well,
okay, so
that's just how this class goes.
Okay, so the 19, I had another duh moment. Define margin of error of 95% confidence level. So
to do this one,
I plugged them in. I think I saw it on the screen, and I subtracted the upper from the lower. Is that the margin of error?
Yeah. So you take the upper, and then you subtract the lower, and then you divide that number by 2.
By 2. Okay, I knew there was something I didn't do. Okay, upper and lower, and then divide by 2. Like I couldn't remember. Okay, so let me divide it by 2 real quick. I didn't divide it yet.
Okay.
So 2.025.
Yep, that's what I put.
Okay. All right, so I'm not out in left field.
Yeah, you got it.
Okay, so then 20, I put 11.168.
That's what I put.
21, 15.217.
Yep.
Okay, 22, I put B.
So I put C on this one, and I'm trying to find out why. So out of the 4 types of confidence intervals, which one is appropriate for this situation?
Now, which one was this one? This was
this is the Hummers.
The Hummers.
Yep. So the reason why I put C down is because the Hummers being sold, I don't think that they depend on each other, the sales.
Okay. I think I was looking at the wrong study when I looked, because I didn't print the information on my printout because I was putting everything on paper. It was missing. I think I was going back and forth from the screen to paper, and I think I messed up.
Gotcha.
So, okay, so you think C on that one?
Yeah, because I don't think that the Hummer sales really depend on each other. I could be wrong, but I don't think so.
Right. I think you're right.
Okay.
Okay, so this is where I got stuck. So 23. So are we running an inferences for 2 means independent samples? I was getting confused about how do you compare the listing price to LA and New York? Because like in the hard part is we're using 2 different ways of calculating it. In SPSS, you have to take, is this when you take the value, recode it to make it a numerical value?
So with this one, I don't know how it works with SPSS, but with Excel, you're doing a 2 sample t-test for the means.
Okay, I think, let me pull mine up, what I have open.
So basically you've got 1 row of variables, and then you've got another row of variables, and they don't depend on each other. So
yeah, independent. Okay.
Exactly.
Okay, so that's what I did. What did you get for 23?
Let's see. For 20, let me go back here. For 23, I put negative 5417.3.
Okay, hold on. You cut out on me.
It's negative 5417.336.
Okay, I got negative 769.741. I do wrong.
Well, I mean, what I might have
What
done
did you
something
get?
wrong.
What did you get? -4. What is it? Did you get again?
Negative 5417.336.
Okay, hold on. And what'd you get for upper bound?
Upper bound, I put 423.238.
Okay, so in SPSS, it's showing those backwards. I just wrote
Yeah.
down the wrong ones. But it's showing my upper bound is 5417.256, and my lower is -423.158. Are you sure you looked at it right?
I don't know. I might not have. But wait, so your upper bound was a little bit off than mine. Mine was 423.238.
Yeah, so when I talked to him the other night, he says that it's not always going to be exact on, but
Oh, okay.
I guess. Well, I don't know how the computer knows that, but
So
I don't know. Can I share my screen and show you what I
yeah,
did?
definitely go for it.
At that, where's my share screen? Okay, do you see that? Let me go down to where I was at. So the T-test right here,
Mm-hmm.
T-test, and it's taking the price from Los Angeles and New York.
Okay.
And then in SPSS, it always says to use the, I thought it's the bottom. Yeah, I think it's the bottom. But if you see here, like, see they're backwards from what you have written down.
Yeah, sure enough. That's very interesting. Huh.
I could do it again. And
I am wondering why. Well, hang on. Let's see. This is still the Hummers question. I'm going to see if I can find that information.
yeah, no worries. I'm not in a hurry.
Oh yeah, I've got it in right here. So let me share my screen with you,
Okay, let me stop mine.
and then we can kind of compare.
Okay.
So let me share, and I'm gonna bring it over here. So can you see this thing here?
Yes.
Okay.
That is so weird. It's backwards.
Yeah, right there. So I don't know what happened.
Hang on. Do you care? I'm just going to run it through SPSS again. Okay. Get rid of my output. Okay. So I go to better headers.
I'm wondering if there's something that I'm missing.
13. So I'm just going to do analyze, compare means. And what test did you run? A one sample t-test?
I did a 2-sample t-test.
So I'm trying to think how I would do that. My options are one sample independent t-test samples or paired samples. It would be paired samples, right?
Well,
Paired
it's
samples.
going to be an independent test. So are you able to put down, is that 2-sample thing independent? Do you know?
Yeah. Remind me, what are we comparing? Again, we're comparing
We're comparing Hummer sales. So Hummer sales in New York versus Hummer sales in LA.
Okay. So to the price, right?
Mm-hmm. Yeah, the Hummer prices, yeah. So in my head, they shouldn't be compared because they don't. They're not going to affect each other. Those the prices for each of them.
Dakota,
Yeah.
my computer just crashed.
Oh.
I'm sorry. Well, I don't think it crashed. I think it had a scheduled maintenance and it just turned off on me.
Oh no.
So I'm on my phone. Oh my God.
Oh
Okay, so bear with me. I'm sorry.
no. Okay, no, that's okay.
So I can't plug mine back in. Okay, well, I guess we'll just do yours. I
Okay.
must have done something backwards. Okay, so I don't have my screen. Can you tell me what lower bound was again?
Yeah, so the lower bound was negative 5417.336.
Okay.
And the upper bound was 423.238.
And I'll just post, maybe it might still let me post it. I don't know. The second one. I'll do my best.
Okay. Yeah, and if it doesn't, I mean,
We got the first part showing me, Matt.
that's right.
Okay. So then I didn't get to any of the rest of the questions.
Okay. So I will run through them with you here. So are we on 25 now?
Yeah, 25.
Okay.
And if you just don't mind telling me, you can tell me the answers and then just tell me what tests you ran and then I'll go through them and do them afterwards if you're okay with that.
Oh, yeah, totally. So question 25, I put ANOVA.
Okay.
And I put down ANOVA because there are there's more than 2 groups that we're looking at right now. We're actually looking at 3 groups of rats. And the researchers are trying to determine the mean levels of bone density between the 3 rats. And so in order to look at more than just 2 groups, you have to do an
ANOVA test.
ANOVA test. Yeah, exactly.
Okay.
Okay. Are you able to see my screen still? Am I sharing that with you?
Yeah, but because it won't let me enlarge it though.
Oh, yeah, that's not going to help then. Okay, no problem. So anyway, there's that. Question 26, I put down 7.978.
Okay.
And I just got that off of the
Testing.
yeah, in this case for an ANOVA test, it's actually the F score. And I don't know what F stands for. I'm sure it's in the book. But anyway, F comes out to 7.978.
Okay.
27, the p-value that I got was 0.00189.
Okay, and that is listed just as p-value, right? Or is it sig?
For me, it says p-value, but it always says p-value on the Excel sheet.
Okay, I think it's sig for me. But
Mm-hmm.
Okay, can you hear me okay too?
Yeah, totally.
Okay.
So, well, are you hearing me okay?
Yeah.
Okay, good. So question 28, I put down D. So there's five answers, and I put down the 4th out of 5, so D.
Okay.
Which says there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Okay.
And I put this down because the p-value is less than alpha. And so if the p-value is less than alpha, then the rule is that we reject the null. And the null in this case, we're still talking about these rats here. This researcher is trying to determine if the mean levels are different between the 3 groups. And so since the p-value is less than alpha, basically what that means is that's the same thing as saying we have sufficient evidence to believe that there are differences in the mean levels of bone density.
Okay.
Does that make sense?
That makes sense. Yep, that makes sense.
Okay. Yeah, it takes a little bit of translation to get that right, but let's see. 29. So I put down dependent samples test, and it's asking for what's the correct hypothesis test for this situation. We're looking at direct flight costs. I don't remember.
Yeah, because they're all
what the data looks like.
Is it because they're all flights coming out of the same airport? Is that why you said dependent?
I'm trying to find out why I said that. Let's see. Oh, I think I put that down because we are looking at the difference between 90 days purchase and 14 days purchase.
Okay, so same airline, same airport, so they all dependent on each other.
That's it. Yep, that's the reason why.
Okay.
So there's a number correlated with the difference between the 2.
Okay.
Yeah. The test statistic for question 30, I have the answer that I put down was 1.685.
Okay.
And basically,
1.685.
Yep. So what I did